we have a volatile liquid that is called the solvent. So this is the solvent in this closed container. Let us call it number 1. Okay, and the solute is number 2. Solute we will denote as 2 and solvent as 1. So this will have the particles of 1, all particles of 1, because only solvent is present here. And this will exert a vapor pressure, say P1 naught. P1 naught is the vapor pressure of pure solvent. Okay, now I mix some non-volatile solute into this solvent. So now the molecules which are present will be of solvent plus solute, which is non-volatile. Okay, and here it was only solvent. Now what will happen? This will exert some vapor pressure that we denote by Ps, where Ps is the vapor pressure of the solution. Okay, now because this solute is non-volatile, so this will cover a part of the surface of the solution. Suppose it will have the particles of 1, 1 and some 2, 1, 1, 2 like this. So particles of solvent as well as solute will be present at the surface of the solution. So what will happen? Now this surface is partly occupied by the molecules of the solute, which is non-volatile. So this part of the surface which is occupied by the non-volatile solute will not allow the molecules of solvent to pass through the vapor state. They cannot escape to the vapor state because this part of the surface of the solution is covered by the molecules of the non-volatile solute. So what will happen? This Ps, that is vapor pressure of the solution, will become less than P1 naught. Okay, that is the vapor pressure of the pure solvent. Now how much it will come down? That we can estimate by the Raoult's law, which says that the vapor pressure of the solution is nothing but vapor pressure of pure solvent, that is P1 naught, multiplied by the mole fraction of the solvent present in the solution, that is say x1. So this is one formula, that is when we dissolve some non-volatile solute in a solvent having vapor pressure P1 naught, then the vapor pressure of the solution will become equal to P1 naught multiplied by x1, where x1 is nothing but the mole fraction of the solvent present in the solution. Okay, now this formula we can again write as P of solution equal to P1 naught into 1 minus x2, where x2 is the mole fraction of the non-volatile solute. Okay, so solvent mole fraction is x1 and solute mole fraction is x2 in the solution. So this we can write as P1 naught minus P1 naught into x2, or we can rearrange this and we can write as P1 naught minus Ps upon P1 naught is equal to x2. Okay, so this we can write this is equal to x2. That is called the relative lowering of vapor pressure, because the vapor pressure of pure solvent minus the vapor pressure of solution, that is the decrease in vapor pressure divided by the original vapor pressure of the solvent. So this is called the relative lowering of vapor pressure, which is nothing but equal to the mole fraction of the non-volatile solute present in the solution. And this will be nothing but number of moles of solute divided by number of moles of solute plus number of moles of solvent. This is the value of x2.